Welcome to the lecture on closures. So closures are an important JavaScript language feature that you will be able to use in order to do a few different things. You'll be able to kind of emulate private variables in JavaScript, which is not something that is really supported, but with closures, we can kind of emulate them. And with closures, we can also create functions that return other functions. And if that doesn't make sense, it will after we go through this. And kind of in the same way, we will be able to store functions in variables to use them later. Let's start with that last point right now. So you may have heard sometimes people say that in JavaScript, functions are first-class citizens. Well, what in the world does that mean? It doesn't have anything to do with geopolitics, but first-class citizens means that you can assign a variable to a function. So we often think of variables like the variable a, we could assign it to the value of 10, or you could assign it the value of like hello world, right? A string. Or you could assign a the value of an array. You could put stuff in it or not. It could be empty. Or you could assign a the value of an empty object or an object with key values in it. All of these are totally normal and fine data types to assign to the variable a, which I declared with a constant. Obviously, you could have declared this with let or var as well. So what we mean by first-class citizens is now you can actually define a function here, like this. So now, a, the variable a, its value is a function. So basically, functions are treated as values. So that's really interesting. What does that even mean? Well, basically it means this. If you have a function and it's treated as a value, well, you could, let's say, we'll just inside of our function, the only thing we'll do is we'll return hey from inside the function. Now, if I were to run this code as is right now, nothing is going to happen because this function is not being invoked anywhere. So how do you invoke a function when it's assigned to a variable like this? Well, you invoke a function just like you would any other function that you, for instance, maybe you define a function like this, foo. To invoke foo, how would you do that? You just invoke foo with the invocation parentheses. So the same deal here. Instead of, the only difference actually is that we assigned this function a variable name, which is a. Cool. So to invoke that function, we just type a and the invocation parentheses. Okay, cool. Let's go ahead and see what happens if we run this. Did we get anything? This editor is not the best sometimes. I'm also noticing my amazing spelling here. Functions. I'm sure you caught that already. But what if we take this code and we put it into a little bit better evaluator? Here we go. We'll do this. And we put a in here. Let's evaluate this real quick. So when we invoke a, it sees that a points to a function and it returns a string, hey, from inside the function. And that's what we get. So awesome. That is the very, very basic point of a closure, which is we have stored a function within a variable. So let's take this a step further, which is that point that I was trying to make earlier here, which if we had a variable inside of our function a, what happens? Let's just call this variable inside. We'll call it inside our function. So now we've declared a variable inside of our function. What would happen if we were to, let's see, I'm sure we can just go ahead and return this variable like this. This makes sense that we can return what inside is when we invoke a. Yeah, that makes sense that we see inside of our function. Now, at this point, I think it also makes sense that we should not be able to console log inside, because inside is a variable that is declared inside of the function that we define on line 1. So there is no inside in the scope outside of the function. Let's check it out. So we get a reference error, inside is not defined. That makes sense to me so far. So that is kind of showing off the property that closures can help us emulate. And let's just say help or assist. They can help us emulate private variables. Because over here, the variable inside is only available if we return it. If I don't return inside and, return what I had before, which was, I think, hello world, maybe hello inside of our function, doesn't matter. But the point is, if I don't return the value of inside, it is only available from within this function a. So when I invoke a, I get hello world, but I can't do something like a dot inside. That gives me nothing. So inside is effectively a private variable within a, even though we don't call them a private variable in JavaScript. Okay, great. Let's kind of go on to the next point, which is that functions can create other functions. And let's even take that a step further and say that functions can return other functions. And actually, let's take away the word other here. So functions can return functions. What does that mean? That means that we're returning a value here, right? Within our function on line 3, we're returning a string. Kind of before, we were saying we could return an array, or we could return an object, or we could return a number, right? We could return all of these things. In the same token as what we discussed, that functions are treated like values in JavaScript, you can return a function from within another function. So let's have another function here. So this function, what do we want this one to do? What do we want this inner function to do? Let's just return hello from the nested inner function. Okay, so now what's going to happen when I invoke a? Before we run it, let's test our understanding here of scopes. So when I invoke a, actually, before we even do that, we need to start at the very top of the file. Starting at the top of the file, we see that we're declaring a variable a, and it is equal to a function definition. So when I see a function definition, I automatically just skip this because this code has not been invoked yet. So I skip it and I go down to line 8. I invoke a now. So now I can go up to a's function definition, which is here. So let's look at this function. What is a doing? It's declaring a variable called inside, which is inside our function. That's our quote unquote private variable. And finally, what does a do? Functions always return something. In this case, our function a returns another function. So you'll notice that we're actually not invoking this function, right? We don't see any invocation parentheses anywhere. That's these guys, like on line 8. So all a does is it just returns another function. So do we expect to see hello from the nested inner function? No. Because this nested inner function is not being invoked. Just like we had to invoke a with the invocation parentheses, we would have to invoke this nested inner function as well. So how in the world do we do that? Well, there's a couple of different ways to do it. You see that actually the return value that we got here it's just saying that the return value is a function. It's actually not printing out my whole function here. But how would we actually get this value, this return value? Well, if you have guessed this, you could assign already, then you're right. You could assign another variable like variable b equals a. So now b is whatever is returned from a, which we just said that a returns a function. So now you have b, that b is saying that it is enclosing, b is enclosing this returned function. And actually, it's enclosing this return function and the variable and all of its scopes that this function includes. Because remember, we talked about how inner functions always have access to outer functions' scope, but not the other way around, right? Like we said, we can't access inside from outside of the a function, right? But you could definitely invoke inside, not invoke, sorry. You could definitely access inside from within this inner function, which we'll do in just a second. So now b is this function, like I said, enclosed, and that's where we get the word closure from, but it's this return function's scope and itself. So what does that even mean? It means that when we have b is now equal to this return function. How do we invoke a function? With the function invocation in parentheses. So now let's see what this does. Awesome. Now we get hello from the nested inner function. One more thing that we might want to think about here is, like I was saying, we can access the inside variable from within this nested inner function, because this inner function has access to the a function scope, and it also has access to the global function scope. So for instance, instead of returning hello from the nested inner function, what you could do is you could return inside, like that. Now, let's look at what happens. Go line by line. We start at the very beginning. We're assigning a variable a to be this function. We skip the function definition because it hasn't been invoked yet. We go down here and we say, hey, we're assigning another variable b to be whatever is returned from a. If a returned the value 10, then b would be 10. If a returned an empty or an array, then b would be a reference to that array. But we look at a and we invoke it. Let's go back to the definition. We declare a variable and we return a function. We return another function, because functions are first-class citizens in JavaScript, that returns this variable inside. So will this work? Are we going to get a reference error saying, hey, inside is not defined in this scope? Let's find out. So that is what b is. B is this function enclosed within b. And not only this function, but its entire, here's another fancy word, our entire lexical environment. So all of the variables that are available to this function are also available whenever we invoke b. So for instance, the inside variable, did you think that it would throw an error, or it'll be fine if we try to invoke b. Because when we invoke b, we look and see, okay, what is b? Well, b is assigned to the value of invoking a. We look at a and we say, oh, it returns a function. So that means that b is this function, which means that we can invoke b, right? And what do we get back? We get our inside our function string. So hopefully this helps you understand a little bit better about what closures do. You'll see a lot more complicated closure examples. But the main thing is that you have to remember that the closure just means that you are storing a function in a variable. Not only are you storing the function definition in the variable, you're also storing its entire lexical environment, which that's just a big fancy jargon word that means lexical just means like location. So it just means along with the function definition, you're storing every variable that is available to that function definition. So that when you use that function later on, that lexical environment, that the fact that inside is, it was only declared within the function a, and a was already invoked. So you're like, okay, well maybe inside this variable is, I don't know, destroyed or something when it's done. But actually it's not. When we enclose the function returned by a inside of b, like I said, like we keep saying here, all of the variables, there could be a lot more variables that are used by this function that we're storing in b, and we can invoke b whenever we want. So let's see if there's any last points that I want to make here. This is kind of related, kind of not, but I would highly suggest that you, and actually I'll write this down here, highly suggested to use let always instead of var. I'm going to say use let instead of var. It's because let has a more predictable behavior than var. And there are some examples you can look at, especially using for loops. If you use for var I equals 0 and not for let equals 0, you'll see unpredictable results. So highly recommend to use let instead of var. Also, what was that last point that we were making? Sorry, I'm jumping around here a little bit. That last point was that when you store, how about this? When you enclose, when you make a closure, when you store a function as a value of a variable, when you do that, the JavaScript engine stores the function definition, which makes sense. Okay, fine, we get that. And also its entire lexical environment. At that time. That's like the TLDR, too long didn't read of closures. I think, is there any other miscellaneous things I wanted to talk about here? Yeah, let's look at one more thing here, which was this. So we invoked b down here on line 9 to get the value of inside our function. So you could also get that value one other way, which would be we invoked a, right? And a just returns this function that is enclosed in a. Actually, a itself is a function that's enclosed, but when we invoke a, it returns a function. Another way to get, or another way to invoke this function that's returned by a, is to actually just use invocation parentheses again. Now this looks a little bit weird and you probably won't see it very much, but it's just good to realize what we're doing here. If I invoke this, check it out. You get the same result as what we did before. That's because you start going from left to right here and you say, hey, invoke a. Okay, great. A returns a function. All right, awesome. But I'm not running this function. I'm not invoking it yet until you see this second set of parentheses. And then you invoke basically up to my highlighted cursor here. This area is now kind of representing, it evaluates to this inner function. So when I use the invocation parentheses again, it actually invokes this inner function. So that's interesting. So you could imagine a situation where you might have a bunch of inner functions that are nested within one another and you can invoke it like this. This is not very readable, is it? But it makes sense how it works. You probably won't use it in real life though, right? So the last little point that I wanted to show here is one other way that we could get the value, the one other way that we can invoke this inner function. So far we've been enclosing it in variables. We use the double invocation parentheses, but there's one other way you could do this. And this definitely freaked me out when I first saw it. But if you wrap this return value, if you wrap this function that we're returning from a in parentheses like that, if you wrap it, so far it's doing nothing, right? This doesn't do anything if I run this because I'm not invoking anything. And actually my editor took away the parentheses. Don't do that. But if you wrap it in parentheses, the function definition, and then look at that. If you add invocation parentheses, oh, I clicked run and nothing happened. Do you have a guess of why that happened? It's because I'm not invoking a. We actually have to do that first. So if I invoke a now, we get this inside our function string that we expect to see. This guy right here is called an immediately invoked function expression. You may be wondering, also, is there a shorter way to say that? Yeah, we call it an IFI, which is a cute name. So I actually like that a lot. This is an immediately invoked function expression, which actually makes sense when you think about each word. It's a function expression, okay, that is immediately invoked when you put these invocation parentheses. The way to do this, remember, is to surround your function definition with parentheses itself. So you may be wondering, like, okay, well, when would I ever use an immediately invoked function expression? You probably won't use it very much. But basically, anytime you write a function definition and you're like, hey, I kind of wish that this function were just like invoked immediately. Like I need to just run it right now instead of running it later. Then you could wrap your function with parentheses and immediately invoke it. So that's just a fun little kind of tool that you can use. And you know what? It's not even really directly related to closures. I just thought I would add that at the end there. So yeah. That is the short, well, semi-short introduction to closures. It gets a lot more complicated later on. But if you just remember that closures enclose a function, they enclose a function within a variable, and that variable, it stores the function definition and its entire lexical scope, everything that function was able to access at the time that you enclosed it, so like when you declared the variable. If you remember that, then you can work through the more complicated closure examples. Thanks a lot for watching. Have a great day.